Hello everyone. In this new video, we are going to talk about the internals of BigQuery. So this is where we start digging into BigQuery. So just to set the context, BigQuery is GCP's enterprise data warehouse. Enterprise data warehouse. That is the meaning of this word EDW. But there is much more. There is much more inside BigQuery, and that is what we are going to explore, as we have already set the context for this playlist for this series. But basically, on GCP, BigQuery will help us to do analytics. On top of analytics, there are various different machine learning use cases that we can solve using BigQuery as well. In a nutshell, BigQuery is a complete EDW solution. However, it is to note that each and every member who is working in a data team may be perceiving or using BigQuery in a completely different way depending on what use cases they are trying to solve. However, before we go into the details or the nuts and bolts of how BigQuery works internally or how exactly the life cycle of a query works inside BigQuery, let's try and realize this, that the basic ideas behind BigQuery are actually taken up from the MapReduce framework. The basic concepts of MapReduce is the same as what we see into BigQuery. Now, before we even begin the video, I just wanted to ensure that we understand what MapReduce means and how MapReduce works. By default, it is a programming model, and it is used to process big data systems, or it is used for processing and generating big data sets with parallel and distributed algorithms on a cluster. Usually, in our experience, we may have seen MapReduce getting used in the Hadoop clusters, right? We may have seen installations like Cloudera platforms and Hortonwork platforms and so on and so forth, where we have extensively made use of the concept of MapReduce. In a very simple nutshell, a MapReduce program is composed of two things. One is a map and the other is the reduce, right? Going by the name, map process is a process that performs filtering and sorting, and the reduce portion is what performs a summary operation, right? It is as simple as that, but it is built or adapted by systems like Hadoop in a way that it becomes ideal for systems that require redundancy and fault tolerance. Now, this is exactly what we will see when we are going to deep dive in the design of BigQuery. Right? So, let's look into the basic design of BigQuery. The basic design of BigQuery can be summarized or will be summarized by this diagram, which I have half drawn. I will be filling up the gaps right now so that I can explain it in a better way. Imagine we have an input table, and the input table can be seen over here, right? If the input table can be logically broken up into files or into sections as stored in the storage, and we are going to talk a lot about what storage this is, how the files are divided, and so on and so forth in the coming videos. But just imagine right now that any given input table, any given input data is pragmatically broken down into multiple different files which is residing in some storage. I have named them as file 0, or it can be file 1 up to file n. So let's say there are n files. There are n files for any given table. Inside the hood of MapReduce, if I want to do, for example, a simple query, if I want to do a very simple query of, let's say, select count star. Select count star from this input table. Let's give this table a name. Let's say this is TBL1. So I want to do a select count star from TBL1 table, right? And I would also like to say where some column C1, which is there inside table TBL1, has a value of, let's say, V1, right? So that is my query which I want to execute. This is plain and simple SQL. So anyone who is familiar with SQL should be able to understand what we are trying to do. We are trying to count the number of rows from table TBL1 where a certain column C1 matches the value V1, right? How will BigQuery execute this? In a very, very simple terms, if there are three chunks, if n is equal to 3, for example, if there are three chunks in which this input table is broken down, then there will be one worker each for each of the file chunks. So I'll just complete this gap by saying that file 0 is processed by worker, this worker, let's say that's worker W0. Then there is one more worker, let's say W1, one more worker, let's say there is W2. W1 will be processing file 1 and W2 will be processing the third file. Assuming, we have just assumed this, that n is equal to 3. Hence, we need only 3 workers. Once these workers read the file, the operation that we are doing over here is read. We are simply reading the data from some storage. We are going to talk about storage a lot, as I said in the next videos. But these files are there in some storage, and these workers are simply reading the files. Once the workers have read the files, they'll further process it or execute this query that as an user I have submitted by means of a shuffle system. So each and every worker sends their respective outputs of this query. They will execute this query on each and every chunk, on each and every file block. So this is file 0 that worker W0 has read. This is file chunk file 1 that the worker W1 has read. And then again, this is file 2, right, which W2 has read, right? All of these files are being worked on these workers, and the workers are individually running this query, select count star query, on these blocks. And then by means of a shuffle system, the entire thing, the output of each and every worker is getting combined. And then there is this single worker who is finally, let's give him a name as well, right? So the final worker W3 over here is going to take the shuffle outcome. This is where all the outputs are getting combined. The worker W3 will take the output from this shuffle stage, which is a combined output of all the workers W0, W1 and W2, and it is going to produce us with the result, which in this case is going to be a number, right? It is simply going to be an integer, right? Since we are doing a count star, it is going to be an integer. So basically, this is how BigQuery executes a simple query, right? A simple query like select star. So if I want to, let's say, summarize this, how can I do this? For each and every query that is run on BigQuery, we have a map stage, right? We have a map stage. I can call this a read operation that I'm doing over here is nothing but map. It is similar to map, right? We are reading the data, we are filtering it. So we are not only reading the data from the chunks of table TBL1, but we are also filtering it basis the condition that we have given, right? So when we read file 0 by W0, W0 is also reading only the rows where C1 value is equal to V1. Again, for file 1, the C1 column value should be equal to V1, which will be read by worker W1. And then again, for file 2 also, the chunk file 2 of this input table TBL1, right? The column C1 should have a value equal to V1, which is read by worker W2, right? That's the map stage, where the data is mapped to the specific workers and may be filtered or sorted depending on the query syntax. Further, the resulting subset, so that is stage number 1, that's step number 1. Step number 2 is further all of the outcomes of this map stage or the workers, right, are flushed into an intermediate stage called the shuffle stage, right? They are flushed into the intermediate stage. This is where the flushing is happening, right? They are flushed into this intermediate stage, otherwise known as the shuffle system. Now finally they are reduced, right? This is where the reduce operation is working. Finally they are reduced, right, into the output stage. We will go into depth of how each and every query works, how the slots are utilized, what itself is a slot, where is this storage, how are these guys really communicating with each other, what kind of network is used within them, right? How are they doing it so fast, or how will the workers do this for a very big table? For example, if TBL1 is a table that is 1 or let's say 5 terabytes of data, and I'm going to run a select count star on that table, how effective will be BigQuery? So we are going to discuss all of those in the coming videos, right? But as of now, the summary is this: we have a map stage, we have a shuffle or a combine stage, and then we have a reduce stage. And very interestingly, we need to note this, that every input data, right, every input data on which BigQuery is going to work, in this example that's TBL1, right, is seen to be chunked or divided into parts, right? Each worker in the initial stage, that is the map stage, which is the starting stage, they handle one specific part of the data, right? All of the outputs of these workers are then brought together in the shuffle stage at once, right? All of this is happening at once. They are not happening in sequence. They're happening at once. The moment W0 is done with his or her job, this worker W0 is pushing the output into the combination stage or in the shuffle stage, right? Same happens with W1, same happens with W2. All of them are working in parallel, right? Finally, the result is output by one or more workers. There can be more workers in this stage, and we will come to those examples where there can be more workers, right? This is how the entire system works. Now, for this to work effectively, we need substantial improvements over how we know MapReduce to work, right? We have to do this in a very interesting way. We have to do this in a very computationally effective way, right? We have to do this in a very good way, right? We are going to discuss how BigQuery does this in the following videos, right? But as of now, this is what is the basic structure. This is what is the very basic structure of how a query gets executed. Thank you.